Hi, Stuart here. Today we're going to talk about DORA and how most people do metrics is wrong and how DORA is one of the 3 ways to do metrics right. So DORA was developed by the people in the Agile community who actually believe in the fundamentals of Agile. That is the sort of people who came up with the Agile manifesto and have tried to do and execute based on that manifesto. There are a lot of false Agile methodologies out in the world, things with Agile in the title that aren't Agile in spirit. That's a topic for another day. But one of the things that the community has been thinking about is what to measure and how to measure it. And someone had an epiphany, or several someones, that said, you know what, we ought to be focusing on the outcomes and not the process. That focusing on the process focuses your attention on the wrong thing. For example, businesses don't focus, on the process when they release a financial statement, right? Or a balance sheet. They focus on the outcomes. Did we make money? What is our debt to equity ratio? And so on. So it's useful to have a set of metrics that focus on the outcomes. And that's what DORA is all about. DORA is one of the 3 axes of metrics that are used by organizations who are really interested in measuring outcomes and then trying to tune what they do to deliver on those outcomes. So the other 2 axes, if you will, of metrics that are outcome oriented are financials and risks. And for financials, what you want to do is you want to measure how much the darn thing costs and what are the benefits that come out of that? And if the benefits don't exceed the costs, then the thing that you've done is not a great outcome. And in fact, you should do this when you're doing planning to see if it's a good idea to even start in the first place. And we have a video coming out on this topic in the next couple of months. We also have some existing videos on managing risks. And again, that dimension is there to make sure that we don't just focus on, wow, we produced a great piece of software in a great way, and it's cost effective and delivers value, but what are the consequences of bad things happening? So risk management is a big deal. I have videos on risk management on my channel that you can watch and enjoy. So let's talk about the 5 metrics and how we compute each one. They're not super complicated, weirdly. Deployment frequency speaks to your ability to deploy. Really successful organizations don't deploy once a year or twice a year. They deploy much more frequently. And in fact, the organizations that are really good at this continuously deploy. In other words, they have many deployments a day. Now, is this a reasonable or achievable target for you and your team where you are at in terms of producing software for your business? Probably not. They have a lot of money to throw at it. They can cost justify the additional overhead because of the need to deploy very frequently. For most businesses, a healthy deployment interval is 2 to 3 weeks with a major deployment once a month. And if you can do better than that, then that's spiffy. And so, the metric for that is that you figure out how many times you've deployed in, say, a 30-day month. But you should always be applying these computations, all of them, to the same time range. So if you're going to compute them every sprint, or you're going to compute them every factor, or every planning interval, or whatever your internal process is, you should make sure that you only count things in the same range for all 5 metrics. But in this example from the DORA website, if you deploy 10 times in 30 days, your DF is 0.33. Is that an absolute metric? No, it's a measure of frequency, right? And what we want to see is that deployment frequency either stays the same or gets better over the stretch of time. And we'll talk about what is a relevant range for that as we go along. Lead time for changes is another metric. In other words, the business says, yeah, I'd really like to have this feature, or I'd like to be able to do this thing or make this change. Then you really want to be able to compute this metric. And The metric can be measured in a bunch of different ways, but the one that I and my team strongly recommend is that you measure the TC, the time for changes from the time of the commit, which is the last time there was a PR for the work item, to the start date of the deployment in which that chunk of change shipped. Now, you could measure from a bunch of different events in the software development lifecycle, but it transpires that these particular 2 points and the distance between them in hours, days, years, whatever, is probably the most stable and consistent of all the different places you should measure from. And so we strongly recommend that this is the computation. And, the lead time per changes is measured as the mean of all of the TC. And again, you don't want to compute that statistic. And again, it's not the value that you get out, right? It is the trend of that value. You want it to stay the same or get better. If it suddenly starts getting worse, then that's a thing that you got to think about with your team. Change failure rate is another good one. This is about the mechanics, right? Are you able to deliver, famously to the Stewart phrase, of the required business value at the needed quality bar on a predictable schedule? And so, CFR is about your ability to be confident when you hit the go button to production, or it's completely automated, which is even more ideal, but not always possible in a lot of business environments, that your failure rate is really, really low. And this one particularly, you have to be acutely aware of choosing too few data points to be in your calculation set. If you've only deployed 2 times, that's great. Those data points will be really useful, but not right this second, because those 2 things are such a small sample size, and they have so much variance inside of them that, it's not a valid measurement. A valid measurement would be to say, okay, we've done this 30 times over a 6-month period, and, this is our trend for CFRs. So you can do the sampling based on the number of deployments per month or whatever. Again, for all these metrics, make sure that your sampling date range is identical, right? If it's midnight from the 1st to the 30th, then that's what it needs to be. However, given the fact that Western months are not even, you're much better off dividing the year into quartiles and doing your metrics, per quarter or whatever. It's much more likely to be a statistically defensible sample size. Mean time to recover is also a thing. So if you have an outage or an incident and there are alarms and allegations, then you need to be able to measure your ability to troubleshoot and correct those. Now, sometimes outages are through no fault of your organization, and there is absolutely nothing that you could do about it. Some people have argued that in those cases that the data point ought to be left out of the mean time to recover. A real world example of that is that you depend on AWS or Azure or Google or whatever, and their cloud in the region in which you host your software goes down, or what's worse, goes down globally, which, that's happened. You can debate whether or not that particular thing should or should not be in the set of data points you collect and measure with this. And I would say, again, you need to be very careful about the date range here, and you need to be very precise about how you measure incident time span. And incident time spans are typically measured in 15-minute blocks. You can do it in minutes, but minutes gives you a false sense precision and accuracy. Generally speaking, the start time for the incident is reasonably easy to determine, and the end time of the incident really doesn't end until the users are informed that the system is available. Whether they act on that or not is outside of the measurement. But you're not done until the people who need that system are told they can have it back. So again, the MTTR here is just the mean of all of the incident time spans that are in your sample set. And if you are reporting and you deliberately exclude an incident from being in your sample set, you are obligated to put that in a footnote or something to just say, we didn't consider these 3 points because we got nailed by our cloud provider and they're not in our control, so we don't think it's fair to measure the incident recovery time because there's nothing that our team and our friends, in infrastructure and so on, could have done to remediate this incident, right? We had no control over the timeline. But you need to make sure if your metrics are going to be considered credible, to call out those things separately. RI, reliability index, is, wow, the most jukeable of all of these. And we'll talk about that another thing. But essentially, it's been really hard to come up with a computation for the reliability index that everybody is willing to bite down on. This is the one that me and my group use and recommend to our customers because it involves 2 different measurement axes, both of which are important, which is the hours impacted. And again, if you're measuring the previous metric in 15-minute slices, then it should be the number of 15-minute slices rounded up. And it also considers the severity of the problem. Right? So, you ship a thing and on some page there's a misspelled word. That's, 4 or 5 in triviality. And so we should adjust the amount of hours that impacts by the inverse of the severity, right? To get dinged for a misspelling in the same way that you might get dinged for a data outage is not reasonable. So our thing is you take the HI and the SS, that is to say, the hours impacted or the 15-minute periods impacted, again, use all the same time measures everywhere, and compare that and adjust that by the severity score, and then take the mean of that. Because if you don't, if you have a one-sided thing and you just count hours impacted, you're going to have a trend that doesn't tell you anything about how horrific the outage was or wasn't. Things that have very high impacts tend to impact the RI score very greatly, and trivial things almost none at all. And that is, in our opinion, how it should be. This particular metric, right, is highly discussed in the community, but this is the one that we think is statistically defensible. So now that you know the 5 DORA metrics, right, we should consider some things. Again, you want to make sure that you're collecting the input data for all these metrics from the same place in the same way every single time. If your collection methodology varies or you're forced to change it somehow, that causes a discontinuity in your metrics timeline, and you have to start reporting this as the version 2 of the metric set because you're no longer collecting the same data in the same way. And the other thing is that you have to have a really crisp and unvarying definition of what failure means for some of these metrics. So if the different people are computing these metrics from different bases and they're interpreting failure differently, your metrics will be wildly uneven and you'll be unable to statistically defensively look at the trend lines for these 5 metrics on a chart and make any articulation that's credible. You just can't. Everybody's got to compute in the same way. Everybody's got to come to agreement on what the data source for the inputs are and how things are computed, including failure. And honestly, failure is and should only be measured by the business, right? At the end of the day, most of us are not producing software that goes on a shelf or gets installed, is a commercially sold piece of software. Most of us are making software for our internal companies, or in my case, I'm a consultant, and so I'm helping to make software for the business. And in that case, the measure of failure is very much what the business thinks. And then lastly, as a reality check, you should compare your DORA metrics to industry benchmarks or other teams in your organization. But again, you can only do that if you're convinced that they're collecting metrics in the same way say one way to step away from the collection is to only consider a trend over a big enough period of time that the derivative of that trend, that is the slope of the curve, is something you can compare no matter how the calculation is. Because at the end of the day, we're interested in the trend, which is the differential of the slope of the curve. So, that is comparable across organizations and across industries and across whatever. But comparing individual benchmark values is not a credible way to compare things. It just isn't. All metric systems are vulnerable. Everybody knows Goodhart's law. So let's talk about juking. As a quick aside, anybody who's ever seen HBO's The Wire Season 3 will know what juking is. If you don't know, welcome to the discussion of juking. Juking is interpreting or falsifying data to get the outcome you want. How is DORA jukable? And again, all metric systems are jukable. All mathematical systems are jukable. That's why I've spent a fair amount of my life trying to look at data sets and find out by doing analysis if they've been fiddled with. So, here's the 5, grievous sins of juking DORA. And by the way, a lot of these apply to other metrics systems. But again, we like DORA because we're trying to measure outcomes, right? We're not measuring the process. We're measuring what came out the other end. We can treat everything in the middle as a black box as it should be. So, if you don't use the same time range for different for all the DORA metrics, right? As we've said like 4 or 5 times now, that's a bad thing. If you add coefficients or fiddle the coefficients used in calculations of individual metrics or sets of metrics, if you are inconsistent in calculation, again, I talked about that. You have to agree as an organization. This is where the data comes from. This is how we use it to compute this metric. This is what makes the date range valuable and so on. And a big one is lack of transparency. For the life of me, I cannot understand why organizations that want to be agile would be so paranoid about not sharing metrics, at least within the organization. If you're in IT and you work for the organization, or you're in business and you work for the organization, you should have access to the metric store for this and the trends and everything else, because you can't make judgments about the thing you're trying to do unless you can see them. And so arguments that say, well, this is pretty confidential business secret sauce. No, a trend, right? The differential of a curve is in no circumstances secret sauce. It's math. So sharing is caring. If you're on a metrics project and you have concerns about transparency, then your metrics process is juked by definition. And again, using too small a reporting period. So you can collect individual metrics every 10 days, for example, but you shouldn't report on one 10-day period, because one point is not a trend. And at the end of this presentation, we have some thoughts on the statistics behind, validating these things. So the other thing is, I've been in so many crazy meetings at so many customers where people insist on focusing on the values rather than the trend, because values are sensitive to not only juking, but changes in approach over time, whereas trend tends to be a very stable thing, because again, it's about a curve over time and taking the differential to get the rate of change. That's the thing we care about. Are we getting better or getting worse? That's what outcomes actually mean. Better or worse? We're the same. Same is okay. By the way, you can't say something is better or worse if it's not outside 2 standard deviations of the mean that you're calculating. I can't tell you the number of times I've been in a meeting and somebody sees that some metric has dropped by whatever, and they say, oh, this is horrible, or this is awesome. And I'm like, well, the mean is this and the standard deviations are that. So in fact, if you apply the student t-test to all the other data points in the line and the data point you selected, they are not statistically significantly different. So don't do that. And the other thing is, I've been in a lot of meetings where people have a lot of arguments about not what the trend that we're looking at to determine the outcome means. That's a pretty valid thing to discuss. But having agita over, again, individual metrics or really small time periods. And again, when you do that, you're focusing on the process and not the outcomes. And DORA is about outcomes. So that's me. I will post the slides to somewhere as well. And in the slides, we have an appendix that talks about computing sample size, the number of data points, how to do the statistics. My name is Stuart. Thank you for your kind attention.